Okay? Remember, did we finish it? We got the answer. We knew what the acceleration was? Okay. All right, let's... We found the normal force, right? We found one thing, right? We found the normal force? Okay.
If it's 0, they just draw on the line.
Yeah, but draw on it. Or you can mark it up there and mark 0 next to it.
Okay.
Okay, that's fine.
So put a 0 in it.
Yeah, put a 0 next to your line if you want. Okay. All right, so we've got our box on the ground, okay? And we have this rope pulling F of t, and it's at what angle? 30 degrees? Okay, right? Everyone with me? And when F of t was equal to how much? 60 newtons, and the mass of the crate was what? 100 kilograms, right? Okay, so we ended up doing a free body diagram, right? Right, and the free body diagram showed the force of gravity, right? And we showed what other force? What other, girls, listen, you have got to do this. The next exam is going to be difficult. The next exam is not going to be as easy as this last one. It's very important you understand this material. Okay, what other force do I have going up? The normal force, right? We all understand what the normal force is, right? Okay, we'll talk more or look at the videos. Okay, explain to me. What other forces do I have on this? The FT, good. The F of t in the y direction going up. Not ft, y is showing the direction. Good. Y is showing the direction, so this is ftx. Do we draw the ft on here?
No.
Why not? Okay. There's 2, right? But more importantly, that these 2, if I put the ft on here, it's okay to put the ft on, but you can't have both, because the fty and ftx added together are the same as ft. So now you have 2 ft's. Does that make sense? You guys see that? Okay, so you can't have both. Now, having the ft doesn't really help you, so it's always best to keep it in x and y. Does that make sense? Everyone with me? Nino, you with me? Okay, so FTY, FTX. By the way, I'm going to have a group problem set next week for a quiz grade assessment, and then the following week we're going to have a test. I'm going to try and keep... So I'm going to have a problem set. I'm going to give you guys a problem set, and you're going to work on it together, but you're going to hit individual... I'm going to grade those as a quiz grade, and then you're going to have a test the following week. Is that clear?
So quiz, test.
Quiz and then test.
Quiz, test.
Quiz next week, test the following week. Mid to end of the week. Okay? But the quiz is going to be a problem set, so it's not going to be a traditional quiz. So a problem set for a quiz grade. Okay? All right. Or I might make it a homework grade if we have homework still listed. I might make it a homework grade or something. I don't know. I gotta go look. I might redistribute. I'll make it a quiz grade. Maybe I'll redistribute the homework grade like I did last semester. All right. Okay. So we've got this. So what is my next step? I've got my forces. What does a free body diagram do for me?
Shows you all the forces.
Shows me all the forces. What mathematically? What do I do?
Variables.
I have to create a what?
Equation.
An equation, the sum of the forces in the x and the sum of the forces in the y, right? What are my forces in the x? Beautiful, ftx. I only have the 1, okay? If I have 1 ftx, I know it's non-zero, right?
Yes.
So therefore, the sum of the forces are what? Non-zero, okay? fty, what are my forces in the fty? In the y direction. Some of the forces in the y, excuse me, I'm sorry. Some of the forces in the y, what are my forces in the y? FTY. Sorry. Oh, FG you said, I'm sorry, FG. FN, the normal force. Not the natural, the normal force. I know where people get, I never have said natural, but everyone's like natural force. No, normal force. Okay. All right, so in this case, what is this going to equal to? Okay, we don't necessarily know, but we're going to assume that it equals 0. When we assume it equals 0, what are we assuming about the crate in the ground? It's not moving, it's resting on the ground. That's if we have our sum of force equals 0. No, well, for what?
For being late to the other class.
But you're not in my class. Get it from the art folks. Okay. All right. So it's shh.
He's in art class.
He was doing 3D printing.
That's right.
Yes. Okay.
Never mind.
So we have to assume that the net force or the sum of the forces is 0. If we assume the forces are 0, then in this case we're assuming that the crate is resting on the ground. Why does 0 mean it's resting on the ground? No movement and therefore no what? Specifically? Acceleration and therefore no force. Right? No movement, no velocity means no acceleration. Because force is mass times acceleration, not mass times velocity, right? Okay.
So technically it could be moving at a constant velocity?
It could be moving, yes, technically exactly right.
Are you freaking kidding me?
Take 2 again.
It is literally
Okay,
the
look at
only
that.
one-
It's like we did the exact same throw. That was awesome. Okay,
Lauren is the only one that gets candy.
did you say it?
And then
Okay.
he feels bad because everyone started complaining and then he gets more.
I literally did. My last class, I asked a very complicated question. And everyone said the exact right answer at once. I literally was like, candy for everybody. And I threw it. All right. Okay. Well, if I did it every day, it wouldn't be special. Okay. So, shh. Okay. Guys, acceleration is 0. But to your point, Lauren, it could be at a constant velocity. But our constant velocity we're assuming is 0. Okay, so it's resting. If that's the case, if it's resting on the ground, what is the sign of my normal force? Why is it positive? Right, beautiful. Okay, so again, let's just sort of do the equation. So Fty, the value is 60 newtons times sine 30. Ftx is 60 newtons times the cosine of 30. This is 30 newtons, okay? And this is 30 cosine times 60 is 52 newtons, roughly. Okay? Everyone there with me? You see what I did? Yes? No? Lauren?
60 newtons
But is it
times cosine.
Fty and Ftx. 60 newtons times the sine of 30. It's SOHCAHTOA, right? Do I need to go through the SOHCAHTOA steps? Okay. Equals 30 newtons. Ftx is 60 newtons times the cosine of 30, 52 newtons. Okay?
Why do you have to do that for FTX?
Because, well, what's the value? How else would you find the value of FTX? At some point, you're saying, why do I ever need it? Because my questions were, what's the value of F of n, the normal force, and then what's its motion? And the motion is going to be the horizontal motion is still part of the motion. Okay? So, the one thing I'm missing is FG, right? So what's my FG? How do I figure out FG? Yes, sir.
Or, no,
How do I figure out FG? What is FG? Force due to what? What's another name for it? Common name. What? Weight. The common name for force due to gravity is its weight. Everyone say that. F of G is the same as weight. Ready? F of G is the same as weight. Yeah, that was. Didn't we just have a nice chorus? That was so horrible. You should learn from the chorus. All right, so choir. was,
Of course.
yeah, chorus, choir, same
They
thing.
did sing of course, man.
Yeah. All right. So f of g, what does f of g equal?
Wait.
Mass times acceleration due to gravity. Force of gravity is also called weight, but it is equal mathematically to the mass times. I was sitting there going, someone's going to say weight. Someone's going to say. Okay, so what's my mass? What's my mass, guys? 100 kilograms. What is my acceleration due to gravity? So my force of gravity or my weight is equal to what? What is it? Negative 1,000 what? Newtons. Nice.
I'm not honors.
You're, oh shoot. Sorry. I thought
Now you realize that, you know.
Oh yeah, it's like they probably know. There you go. First two problems are the same. Last one's different. Sorry, kiddo. All right. Okay. Shh. So now what am I going to do? Guys, let's focus. What are we going to do? How do I? Thank you. So FTY is 30 newtons, right? Plus FG, which is what? Negative 1,000 newtons. Plus my Fn, which I don't know, is equal to 0 newtons, right? Yes? Okay. Therefore, my F of n, my normal force, must equal 1,000 newtons minus 30 newtons, which is equal to 970 newtons. No. It's plus your Fn, right? It's plus Fn, I'm sorry, plus Fn. So it's normal force. 0, right? Newtons. So, guys, don't just blindly write down what I'm writing down. Follow it here. It's not that light. Okay. Yeah. I can't hear it. What? Okay. Plus normal force equals 0. Now I'm going to do some basic algebra where I solve for f of n. I'm moving each side to the other side. So I have to add 1,000 to both sides and subtract 30 from both sides. Okay? So, yes, because I have to. This is basic algebra, guys. You've got to get Fn on it by itself, which means you have to get rid of it from this side, but you have to do the same thing to both sides. So you have to add 1,000 to one side and add 1,000 to the other. Okay? Then you have to subtract 30 from one side, and you have to subtract 30 from the other. Add 1,000 minus 30. I'm gonna, guys. You all, I'm so serious about this, and I mean no disrespect by any stretch. I'm doing this for your own good. You all need to go and get an algebra tutor and relearn algebra. I'm really sorry, it's an issue. It's not just you guys; it's the entire grade. If you're solving for f of n, you've got to get f of n by itself.
But you can just combine the like terms right there.
Okay, so it's still going to be 970. You can do whatever you want. There's 5 different ways to do this. How is it that you do it?
I did it like that. You combined them.
Okay, but you should be able to see the difference. Listen, I just don't know. But you should have been taught the number of ways you can do it. There's not just one way to solve this problem. You can solve the problem a million different ways, and you need to be able to see that. And I am just stating, for life, guys, you've got to learn algebra. You've really got to learn it well, okay? And it's not just you guys; it's the grade as a whole. There's just this. There's something missing at the algebra level. We're just not there. It's not your fault. It is not your fault. I'm not saying that, but you've got to fix that. You're gonna have problems. Okay, let's move on. Let's move on. So, what is the sign of my normal force? Positive or negative? Positive. What does that mean? What direction is my normal force now, son? So if my normal force is going up, what does that mean about the crate? If there's a normal force, what is the normal force? What is it? But that's what it means, but what is it? What kind of force? Why does it even exist?
It's the force of whatever's ground.
Okay, it's the reaction of the table or the ground pushing back on the object that's pushing on it. Okay? The table or the ground's always going to push back at whatever's pushing on it. That is the normal force. Normal just means the direction. It's perpendicular. It's always going to act and react perpendicular to the surface that that object is pushing on. Does that make sense? So in this case, if the ground is pushing up, what must be the case? Something must be pushing against it. It's not going to push back without any reason, right? It's got to push back against something pushing on it. It's not going to throw a punch without having the punch thrown at it first. Okay? So you've got to have... Cannon's like, I can't handle these ridiculous analogies. So you've got to have it. The direction means pushing up means that there's something pushing back. If I solve this and I got a negative number, what does that mean? No. Let's think about this. Do you guys remember me? We did the scale bit last week, right? Or earlier this week we did the scale. Well, let's think about this. Who was standing on the scale? Nino was standing on the scale, right? Do you guys remember this? Anybody?
Yes, everyone remembers it.
Okay.
After 2 days.
So let's do it again because it's important. Okay. I need my rope. I need someone small. I can hold on to a rope. Nina's too tall. Here. Come on. I'm not gonna touch her. Promise I won't touch her. Okay. Hold the rope. Hold the rope. Who's the smallest person in the room? Hold on. Hold on. Hold hands. I'm gonna pull you up. Okay. Now, watch the scale. The scale reads what?
500.
It reads like 95. Okay. So now, hold on. Okay. Now I'm gonna pull. Watch the scale. What happens to the scale? Look at the scale. Pull with me. Pull against me. Pull against me. Okay. Keep going. Keep going. And what's the scale doing? The scale's going down, right? Okay.
Yes, no.
Okay. Okay. Come here. Let's do this. Let's stand on the scale. Cannon, come over here. Cannon, come over here. Cannon, here. Can you stand on the scale? Do you mind if we pick you up? Stick your arms out. Okay. We're gonna do. I'm not gonna tickle you. Stick your arms out. I'm gonna pick you up. Okay. Okay. So now, the scale reads 110, 115. Okay. All right. Now we're gonna lift up a little bit. Okay. Lift up, Cannon. Lift up. What does the scale read now? It reads 50. Okay. Lift it more, Ken. Now read 40, 30. Okay? Let's think about what's happening. Hold still. Think what's happening. Right now the scale reads 110, okay? She has a weight of 100. It's going good. Stop. Shh, guys, let's be serious on this. Important. Hannah has a weight of 110, 115, whatever it is, okay? Shh. Hannah, stop. Okay? Right now, what is supporting her weight? What is the scale? The scale is pushing back the same amount that she's pushing down. When Ken and I push up, like the rope, pulling it up, what happens is the scale has to do as much work. No, but it still has to support some amount, right? If we were lifting our entire weight, what would the scale be? 0. Okay? Now, if we're going to continue to lift, we're going to lift, and the scale's going to go from 115 to 100 to 70 to 40 to 30 to 0. When it's at 0, our force is equal to what? Per what? Per weight. Okay? Now, let's say we apply even more force and we lift her up. We accelerate her upward. If the scale was attached to her feet, what would the scale then read? Negative. You guys see that? It would read negative if the scale was attached to her feet. And we stretch the scale. You guys see that?
Yes.
So if the normal force is negative, it means we're applying extra force upward. Okay? Does that make sense? Does that help? Okay, good. Thank you very much. Thank you guys. Okay. It's an important concept to understand. Okay? It's an important concept to understand. Do you guys get that? Nino, get that? Tara Jane? Okay. All right. Very important. Now, we're going to finish this up. Now we're going to have the if the normal force is positive, that means the box is doing what? Which direction? Vertically, it's not moving. But is it moving horizontally? Well, let's look. What is my FT value? My FT value was what? 52 newtons. Positive to the right. That's the force to the right. What's its motion? Is it accelerating or has a constant velocity? Let's think about this. There's a force now of 52 newtons being applied. It's accelerating. Okay, because what does force equal? Mass and acceleration. Simple as that. If I have a value, some number for my force, obviously we have a mass, then we have to have an acceleration. And if we have an acceleration, what does that mean by definition about our velocity? It's not constant. It's changing. That could be decreasing, right? It means our velocity is changing. Understood? Not constant. So that means 52 newtons equals what's our mass? 100 kilograms, right? Times the acceleration in the x direction, right?
Right.
So acceleration in the x direction is 52 newtons divided by 100 kilograms, which is 0.52 meters per second squared. That's the acceleration rate. It's accelerating at 0.52 meters per second squared. If we pulled at this constant force for 1 second, what's the box's final velocity for 1 second? If we're pulling this box with this FT at 60 newtons at 30 degrees, what is its horizontal velocity after 1 second? 0.52 what? Per second. Because it's accelerating from 0 to 0.52 meters per second in 1 second. After 2 seconds, what's its velocity? 1.04 meters per second. 1.04 meters per second. Do you guys see that?
Yes.
Right? Okay. Yeah, because velocity equals... Okay. All right. Good. Everyone there?
Yes.
Okay, good. We're going to do a new problem. Are you ready?
Wait, I have a question. So how do you find the total tension of the rope in the diagonal direction? Because hold on. Because we found in the y and then the x direction, but that's
Components.
that.
Components.
But so what is it?
It's the 60 newtons.
But I thought in the beginning we added FTY and FTX to equal FT.
Right. But we're adding it component vectors, not just magnitudes. It's the Pythagorean theorem. It's the trig, right? This FT is, we have FTX and FTY, right? The magnitude of FT is equal to the square root of FTX squared plus FTY squared. FTY squared, right? No, wait. Yeah, FTX squared plus FTY squared equals FT squared. Right? So FT equals the square root of FTX squared plus FTY squared.
But the square root cancels out the square.
No, see, that's an algebra thing again, right? It doesn't, because You have to add the squares and then square root them. You can't just square root each one, and you can't do that. Okay.
How about like it's a squared plus b squared equals c squared?
A squared plus b squared equals c squared. A squared plus b squared equals c squared. So if a squared plus b squared equals c squared, okay? C equals the square root of a squared plus b squared. This does not equal, okay, does not equal a squared square root plus the square root of b squared. Now, if it was that, then yes, this would equal a plus b, but it doesn't. 2 squared plus 3 squared, okay? Let's look at that. That's 4 plus 9. What is that? 13. Does 13 equal 5? No.
Maybe.
Right? 3 plus, right? Okay. All right. Okay. So next problem. Let's do a new problem. Okay? Okay, we've got this sort of rock, okay, sort of boulder here. It's on the ground. All right? I have a couple of things. I'm going to call it F1, okay? I'm going to call this, oops, excuse me, F2. I'm going to call this F3, okay? The mass of the rock, the boulder, is 150 kilograms, okay? F1 equals, F1 equals 70 newtons. F2 equals 30 newtons. Now, F2 is equaling 30 newtons, but it's what direction relative to F1? So it should be negative. You need to make sure you put your negative in there. I'm going to tell you that Fn, the normal force, okay, is 800 newtons positive. Okay? I would like you to tell me two things. What is the value of F3? And what is the motion of the rock, assuming there's no friction? Zero friction. All right? Ready? Go. This is your time. Your time to shine.